All right. Welcome, everyone, to the next Malware Mondays. So I'm fresh off vacation and maybe still a little disoriented from that. So hopefully everything goes relatively smooth today. Bear with me in the case that it doesn't. Um, what I wanted to do in today's stream is just talk a little bit about the PE file format. If you've looked at my channel, you'll see, of course, I have a lot of videos that cover it. I've been trying actually over the years to get a fairly comprehensive playlist of just different aspects of the PE file and things that I think are important, as well as the different tools that we use to analyze that. But I thought today would be just in context of this whole series. Now is a good time to just to kind of stop and take a look at some of the more important aspects of the PE file. And this applies to other file formats. For example, the L file format on Linux and Mako. They're not identical, but conceptually, there's going to be a lot of things that are going to be very similar. And so learning one can help to identify and analyze those others. And this really sets the stage to understand, what your tools are telling you. We don't want to just blindly use tools like PEStudio or Detected Easy or Malcat without really understanding what they're parsing, how they're parsing it, where there could be, challenges in how they access the data, as it sets the stage as we move into, looking for more signs of packing, obfuscation, and of course getting into some of the reverse engineering. So that's going to be the goal for today. If you've missed any of the Malware Mondays, of course the streams are live. It's great to see everyone here as you join, but those are all now available on a playlist as well, so you can check those out. I believe this is number 8. I've lost track a little bit, but the series will continue well into this year, and I'm glad that you're all here. Let's see, I'm going to start a screen share. And let's go with this layout. I think this will be the best layout for today. We're going to just jump right into the content here. I have a tendency to, manage to talk for about an hour. I guess years of teaching has just made my presentation style kind of center around that. So, that's probably how long this live stream will be, give or take. Questions, if you've got questions, please feel free. This is a stream that is available for everyone. I say that, I guess I should have probably, let's see if I can find my YouTube channel here. I do want to announce particularly, or at least draw your attention to, I do have memberships open. And so this is a new part of the YouTube journey for me. There is going to be, if you go to the join tab, I guess you have to sign in. I forgot to do that. You'll see the different membership profiles and levels, different perks. I have three levels, different perks for the levels. One of those will be, certain live streams will be members only chat, and there'll be some members only content. As you can see down here, I think I've got a couple of members only videos, certainly some early access to videos as I produce that. So do check out memberships, a lot of great perks. And of course, if you have any feedback on it, things that I'm, again, doing well or not doing so great, or you think could be added, definitely let me know. There's a number of ways to get a hold of me. Comments are open inside of YouTube. Social media platforms such as LinkedIn and Twitter or X is also very easy to get a hold of me. A couple questions coming in. Thanks for hosting the event. You're absolutely welcome. I'm just glad to see the turnout. And the point of these is that you find them useful in your cybersecurity career, your education, and your learning. And so that's the number one goal for me. Another question here from Kelly: is this available to watch again later? Yeah, absolutely. This one looks like it's coming from LinkedIn. I'm not entirely sure how they work on LinkedIn, but I think these live streams are available somewhere there in my profile. The real home, though, and the way that I'm probably paying the most attention to how I organize them is on YouTube. So if you go to the YouTube channel, as you see here, not only do I have some upcoming live streams, and this is another thing I guess I need to promote, but there's also not only the past live streams, but here is the Malware Mondays playlist. So these will be in order. Maybe I need to reverse this so that it's the newest to the latest. That's probably what I should do. I'm going to take a note of that and get that done. I'll just say reverse order. So those will definitely be there. Okay. Yeah, I guess upcoming live streams. I do a pretty good job, hopefully, of promoting things via social media, but I've got a new format coming, and that is to add to this Malware Mondays, format. And these are going to be more interview kind of guest driven. I've got two folks already scheduled here. Karsten Hahn, Strupigal is the kind of the handle that he goes by. He's going to be joining me here in a couple weeks on the 5th of September. And we're going to be talking about how you identify essentially false positive or clean files. I think that's a topic that is just not discussed enough. It's not really taught enough. Like when we teach a lot of malware courses, a lot of malware content, we just start with malware, and we've already determined it's malware, and then we use that as the foundation. But when you're working kind of in the wild, you never know. You might actually be dealing with a legitimate library or a legitimate executable. And how do what do you look for, and how do you determine that so that you don't waste a lot of time, analyzing it when it's actually a clean file. On the 12th of September, then we're going to talk a little network security monitoring with Peter Manev of Stamus Networks. He's also been a longtime member of the OISF, or the Suricata community. So always great to talk about him. We're going to talk threat hunting and just how to leverage the large amount of network data that you can capture in any network, sandbox or a production network, and try to identify anomalies or look for threats. So hopefully you join me for both of those. Okay, now I think I'm finally ready to get started with the actual content at hand here. There's a number of ways that we can grab a PE file. Of course, we're using a Windows operating system, so there's all kinds of PE files here. If you go to, for example, your local disk and see Windows, there's probably some, there's plenty in here. Notepad, for example, was in here. I just saw it. There looks like pi.exe. I know all kinds of files here, .exe files. If you want to, learn a little bit more of the reversing, I have some GitHub repos that will help with that. For example, this learning reverse engineering. The idea behind that is that there's just a number of different programs that I use, much like I'm using in the series, where you have the code, you can compile the program, and then you can look at the original source and the compiled program. So, for example, if we look at this control structures, there's a number of .c files. I think I grabbed if statement, and if we go to, let's go to a developer command prompt. All right, I'm just using this new command prompt in Windows. You can drop down here, makes it actually quite easy. Pick the type of prompt you want. So I've got the Developer Studio. I think that's just part of the Flare VM installation, but the software development kit, you can get it from Microsoft. There's the community edition, it's free. And just switch to a developer command prompt. And really the only thing we need that for is so that you can get the command prompt, the compiler linked to the environment. You could open up Visual Studio, but I find for these small programs, I don't need all of the weight of Visual Studio running in the VM. So hello, Luan. Okay, so we can just say, compile, so CL, and then the source code. So that was our source program. I think I have it open here in Visual Studio Code. Yep, there it is. You can see that. That turns that from the source into an executable. That means that it can be executed by the operating system. Now, you might get an error like this at some point in time, and that's because I have a number of tools that are open, and likely one of these tools put a lock on the executable file itself. So the compiler just simply couldn't open it here. That's usually what that error means. So I could close all of these. I don't want to do that then, because then I'd have to reopen them all in just a few minutes anyway. I've already compiled it, but that's just to show you the steps. If you had any sort of syntax errors, maybe you accidentally typed a key when you were looking at the source, or you're actually making modification. I think that's one of the important things about this, is that these are easy for you now to modify if you know a little bit of C. You would get some errors up in this area here, right? It would say compilation error, compilation warning, and then you'd want to fix that. Once we get the executable, right, like the easiest way of looking for what type of file we're dealing with is typically a file detection utility. Magica is a new one that was released by Google. So I don't feel obligated to show it, but I do think it's neat because it's oddly enough, it's not as good right now on just PE files. Let's compare that to the more traditional file utility. You'll see with file, see if I can get both of these in here. All right, with file output right here, we get, I think, better output. We can see that it's a PE32 plus 64-bit executable, where Magica just says, yeah, it's a PE file, right? But where Magica is really good is when we use, file content that maybe isn't, doesn't have a real defined structure. Give it source code or give it a script, and then it does really good. Or it's, in my limited experience playing around with it, it does really good with helping you to identify what type of content that is, that unstructured file types. So in any case, it's there. Just wanted to point it out if you want to mess around with it a little bit. But file's a good one. And you can see again that file did a pretty good job of telling us that that's a PE file. If it wasn't, right, if it was an ELF file or a Mach-O or just something else that it could detect, it would tell us that. And then when it can't, then it'll say things like ASCII text or binary data, right? And it's got logic inside, of course, the utility to determine that. Now, you'll see that a number of different tools, right? If we use Yara, if we use Suricata, which is an IDS, a network detection engine, any number of things, some of the utilities that we're going to talk about here throughout this live stream, all of them are going to initially identify and parse the file to determine what it is. Because if we take a PE parsing utility and we give it an ELF file or an Office document, well, it first has to understand and determine if we actually gave it a PE file. So that's one of the first things here we're going to talk about. Now, as I've mentioned on the channel, I've got a lot of different videos that cover different utilities. So, for example, I'm going to go to the desktop, and you'll see here is the executable file itself, right here. Let's see, we can right-click in the Flare VM. You'll get a number of different, usually context-aware. Whoops, what I did there. Let's try that again. So I'll right-click. I'm going to try to zoom in. Maybe I can't do it with the. There we go. A number of different utilities based off of the context, the type of file that it thinks we're dealing with, and generally that's going to be not that robust. It's going to be limited more by the file extension. PEstudio is one that I've used a ton throughout the years. You can open it up. There is a free version and a commercial version, but I find the free version to be quite capable. I've got an entire live stream on this one, so I'm not going to spend a lot of time here, because if you're interested, then go check out that live stream. The idea with utilities such as PEstudio, and we'll look at a couple of others, is that it's parsing the PE file for us. It's doing all this work. It understands all sorts of nuances and quirks for the file format, and it's summarizing that data in an easier to consume and digest format. So, for example, with PEstudio, if you look at the left-hand side, this is where it's giving you sort of a summary of how it's analyzed the file. It's saying here's indicators, here's information from VirusTotal if the tool integrates with VirusTotal. Oftentimes that can just be simply generating a hash, searching the hash. Different actual sections and parts of the PE file. That's what we're going to talk about in a little bit. There's this rich header. Let's see right here. Libraries and imports and directories and all this stuff. And again, the purpose of it, as you see off to the right-hand side here, for example, this compiler timestamp, it's saying, all right, this looks like when this was, well, this is the data inside of the PE file format that shows when this was actually compiled. So, great tools, and they're designed to make analysis quicker and easier. Malcat is another one that I've been spending a little bit more time with lately. Let me just reopen this file and see if it can get me back to the home screen. There we go. And it's going to be very similar. I've used this tool a little bit in the last couple streams. I've used PEstudio and a lot of streams. Detected Easy almost always makes an appearance. They're there because they're going to parse the PE file for us and tell us about it, so that we don't have to get into a hex editor and do all of this manual and oftentimes time-consuming investigation ourselves. So you can see, very similar to the previous, there's going to be file information, there's going to be metadata information. It's Yara signatures, so an internal signature engine, as well as I'm sure ones we can add to it. There's analysis with Kappa. We've covered Kappa in one of the previous streams. So if you're not familiar with Kappa, definitely go check that out. It's a great tool that you're probably going to want to add to your analysis workflow. And then just getting into, as you see down in this report section, really getting into sort of the bits and the bytes of the PE file that it's been asked to analyze itself. So this is another great tool, and we'll continue to use it throughout the different streams. And then there's, of course, Detected Easy. As I said, I use Detected Easy almost all the time, and signatures are there right up front, right? That's usually one of the first things I'm looking for. And then if you toggle this advanced, now you have the ability to really dig into and look at different aspects of the PE file. You have the ability to look at some disassembly. We have virus total and Yara integration, calculation of entropy, which is the randomness of bytes across the file, which can oftentimes be a pretty good indication that there's some level of packing, obfuscation, encryption. The bytes are random, right? When we're looking at an obfuscated code, the bytes are a little less random. They're a little more predictable in terms of their pattern. So these are all great tools. And the purpose, again, is just to make it easier for you to analyze. But what you don't always understand then is how exactly are these tools working, and where can there be some limitations. So if we switch gears a little bit and look at that same executable with a hex editor, I'm going to open up HXD. HXD is just a hex editor. It's a very straightforward hex editor in terms of it's going to, as you see here, take whatever content you give it, and you're going to have offsets, bytes, and then an ASCII representation of those bytes. So that's it, right? And if you understand the file format, you can look at this and go, oh, well, like this first 2 bytes here, here's the magic bytes for a PE file, 45A. This last 4 bytes, oops, wrong button, here, all right, that's going to be the address of new, or ELFA new. It goes by a number of different names. But this is going to be the offset to the next section. So F0, if we look down here at the offset, F0, then right here, 5045, followed by 2 null bytes, which you can see is PE with 2 null bytes. That's the signature for the next section. Jermaine, let's see. So question here, can you explain offsets in HXD? Yeah, absolutely. These offsets are really important. Let me scroll out and scroll back in to clear those annotations. This offset column, as you can see here, there's 2 contexts that you have to be aware of, and we'll talk about them. Again, many videos I cover it in a lot of detail, but we'll do that today as well. The offset, when we're looking at this file, so we loaded this file from disk, right? And the offset is just simply the beginning of the file and then the number of bytes into the file. So of course, offset the first byte, offset 0 is at 00, 0. And it's just a row column. Each one of these 4D 5A90 is 1 byte. So we have 16 bytes across this row. That means that the offset for this byte, B8, is at 10. Right. And so these offsets, again, it's just a calculation of the number of bytes into the file. So starting at the beginning of the file, offset whatever bytes in. So offset F0, that's F0 bytes right here. F1 would be here, F2 would be here, all the way through. And you can see that the column headers, right, we're dealing with hexadecimal. So we're 0 through 9 and then A through F, right? So that's the only difference. Now, the offsets in memory are going to be basically the same, right? We're just going to take this image, it's going to get loaded into memory, and you're going to have the beginning of the image and the end, and you can calculate offsets from the beginning of that image, and it's still just 1 byte at a time. What happens though is now in memory, we're typically dealing with virtual addresses and relative virtual addresses. And so we'll talk a little bit more about those here as we go through the file. So hopefully that helps. Malcat. Yeah, Malcat does seem like a pretty awesome tool. It's been great. I've been using it. A lot of features that I'm not even scratching the surface on yet. So this version of Malcat is just, there's a free version, like many tools out there. The light version, I think they call it, and you can go check it out and start exploring. So it's been a great tool. Okay, so we can navigate this if we wanted to, if we understand the file format. Okay, I know that this is the beginning of the next section. Even if you didn't know that offset, right? And so all I did was I took this value. You have to remember the endianness. The endianness is the byte order, right? And so this means that this is going to be the least significant byte, and then these are going to be the more significant bytes. So it's just F0. You just simply add that to the beginning of the file, which is 0. So you just go directly to F0, to that offset. And there we go. You could also just visually look for 504500000, as a human being, and you could recognize that and say, okay, here's where the image NT headers begin. But a lot of times, the tools that are going to identify PE files for you, they're going to say, okay, first of all, can I find MZ? If so, at the 60th byte from that MZ, I'm going to look for a 4-byte value. I'm going to use that to go from, as an offset from the beginning of that content. And if at that location is these 4 bytes, 5045000, well, then I must have a PE file, right? And that's going to be kind of the most basic way of determining a file or looking for PE files in a blob of bytes of arbitrary content. From here, now we have another structure, the image NT headers. And this will go to, about here. I'm just looking at the bytes. It might go a little further, but there's this byte here, and then you see there's a whole bunch of null bytes. So this is probably the end of this region of data, and it's really hard to recognize anything useful out of this. Typically, the only thing you're likely going to recognize is the names of the sections. So here you can see in plain ASCII, we have a few sections. It looks like 5 sections: .text, .rdata, .data, .pdata, and .reloc. And those were created by the compiler, right? Because remember, we took the source code, we compiled it, and now we've got this executable file. And the compiler took care of generating this executable file. Question: where can I see if I'm dealing with a DLL file? Yep. So here's the question. Absolutely, there is a spot in here. We'll get into it in just a moment, because this is hard. Like my whole point of going through all of this is just to show you that this is hard, and that's why the tools that I mentioned earlier, super helpful. But even if we stay in the hex editor, I'm going to just shift over to 010. We can add these templates, and it can help us better understand the content. So we'll definitely take a look at where you can find the DLL, what differentiates it between a DLL, and even 32 versus 64 bits, so that underlying architecture. In just a moment. These section names, though, these can be arbitrary, right? In this case, the compiler added it. They really don't have to be there. They can be modified. They can be randomized. They can just be junk data. They don't really hold any significance to the operating system itself in terms of how it loads this PE file. Okay, once we get past all of those, again, it's just like visually parsing it, and just even recognizing this basic structure can be really helpful. Like up in this first 64 bytes, there's a lot of null bytes here. As we get into this section, the image NT headers, well, there's still quite a bit of null bytes. Between now, the end, so this is the image NT headers and the section headers. Now we get into, oftentimes based off of the alignment of the file, a bunch of null bytes, and then all of a sudden content begins. And so this is just going to be padding between the sections, and this is going to indicate then the beginning of a section, right? Oftentimes. This will likely be the text section because I compiled it using Visual Studio. So usually Visual Studio, in fact, I haven't had a case where it didn't make the text section the first section, that is the section that contains code. And now you just have this chunk of data that, again, we can't really make sense of it just by looking at it. We have to use tools like PEStudio, like Malcat, like Detected Easy. And then ultimately, if we want to understand what this code is doing, then we get into it with IDA and Ghidra and we start reversing it. The sections are as big as they are defined. You can see that's quite a bit of code here. We might be able to, if I get lucky, find okay, so this is probably here, the beginning of another section. And this is just, some null bytes. The reason that there is that padding, I'll show you the section or the part of the PE file in just a moment. There is an alignment, right? And so once a section is defined, it has an amount of data in it. In order to then determine where the next section will come in the file, there is an alignment property both for on disk and in memory that just essentially creates this padding to say, okay, the alignment needs to be at this location. Let's start the next section. In one of the last videos that I posted on the PE file format playlist goes into section alignment, sections and section alignment. Okay, again, you might start to find some strings and stuff in here. In this case, most of these strings, just if you look at the original file, hey, this is it, right? I only have 2 strings in here. So all that stuff's coming from the compiler. Right, okay, anyways, and then we get to the end of the file. If there's an overlay is just data that's added to the end of the file. I've also got a video that covers that. Hard to tell because we're just looking at the raw data. So again, it's good to just kind of recognize and know this pattern. In particular, I find it helpful to be able to spot this at the beginning of a file. Let's say that this was simply XORed with a single byte key. Well, now all these null bytes could potentially be just that key, and you can kind of see the pattern. It'll just kind of look like a PE file because now this region of padding will be all just the same key. Sometimes they don't, like they do null preserving, so they don't XOR the null byte because it reveals the key. And so then you'll see, still see this sequence of null bytes here in the beginning, towards the beginning of the file. All right, but again, this is painful. This is painful. So what we want to do is we can use a tool like O10. And the reason that I like O10 is because it has this template, and it has this whole template library. But you can see if generally it's really good at, you load a file and it says, okay, this looks like it's a PE file, an executable file. Would you like to run this template? And then you run the template, and here we can just do that. So let's open the file. If statement.exe. Oh yeah, that already did it, probably because I've already loaded the file. But you can see the template was ran. If it doesn't, you can just go to the template. You can either run it yourself just by using these sort of pre-filled or pre-selectable options, or you can go to the template repository and you could search for it. All right, there it is, exe, there's Mach-O, there's some other, I don't know what those are, but exe.bt, that's going to be the main template. Question from Luan. Hopefully I'm pronouncing it right. No problem. That's what these streams are for, is to ask questions. I'm just talking to fill the time in between the questions and hopefully bring up some ideas for y'all. Let's see, books or articles about using Python to parse PE files. I can't think of anything off the top of my head as far as like an article. Typically, though, when I do want to do some PE parsing, let's see if I can find it here. Yeah, this is my go-to. I think it's most folks' go-to is the PE file module. It's available here on GitHub. It is a Python module that makes it really easy to parse PE files. And so, yes, I do have some projects, and a lot of people do, where you want to programmatically parse PE files. I mean, you can just open up a terminal. We could just, say like Python import PE. Oh, I must not have it, or I'm doing it wrong. Python's one of those languages. I use it all the time, but yet I always forget. Yeah, whatever. I always forget how to do things in Python. You could just like start writing Python here in a terminal and parsing a PE file. So it's really up to you. Whenever I want to use this module, I go to the, let's see here. I think some of these usage examples here. This always is a great place to get started. Oh, there we go. Import PE file. That's all I need to do. And then path to the executable. And then you can just start parsing, right? Much like we're doing. You just have to, you might have to know the structures a little bit better. But yep. So this is usually the place that I start. And then if I can't remember exactly how to do something in PE file, then I just turn to Google and I search until I find an article or somebody who says how to do it. But I think 9 times out of 10, this gets me 99% of the way there. Yeah, import PE file. Yeah, thank you. So this I think the documentation here is really great. So this is usually where all I do to get started. Yes, you're very welcome. Okay, so yes, we're in O&O. We've got just a sample PE file. Again, you pick any PE file you want, and then we went and added the template. The template now helps us to understand. You can see uh, the color coding, right? And all it's doing now is it's taking these different parts of the file, the bytes and the structures that represent those bytes, and it's color coding them for you, as you can see here. Okay, so the first one, the DOS header, you can look at this type column and you'll see that this is, generally speaking, this is going to be like the actual way it's defined from Microsoft. So the image DOS header is the structure name if you were to try to look at this in the Windows headers files or try to find it online. It's now taken each byte and it's mapped it to the members so that we can try to understand it a little bit better. Um, I don't think I've ever used any of the members except the last. And you'll see that this is called address of new exe header. And it's highlighting those 4 bytes for us right there. And it's also going to give you an interpretation of the actual value based off of the endianness. So F0, if we add that to the image base, that takes us to the NT headers. So we can highlight that structure and you'll see that that starts at that offset, F0. Okay, you'll see there's the DOS stub. DOS stub is going to contain things like the this message here. Again, this is compiler generated, so it's not always consistent. It can be modified, but this program cannot be run in DOS mode. There is a rich header. Some programs will now have rich header information in them right here, and your tools may or may not parse that information. I think rich header is parsed a little bit here by O&O. Can be interesting information. There are some use cases out there of using the rich header information in order to track and kind of hunt for related samples. So can be important, but I wanted to focus on, again, just the actual structure here. Now we get to the image NT header, and you'll see that this has the signature, just like we talked about, right? PE with 2 null bytes. And then there's 2 more structures. There's the file header and there's the optional header. All right, we can continue just to explore those. If you expand the file header, for example, we're going to get the architecture. You get the number of sections. So this value can be accessed in order to determine how many sections the file contains. So you'll see the section headers here in just a moment. There's the timestamp and the interpreted value. I think that's just UTC time from the epoch. There's a characteristics down here below. And this typically is going to tell us things like it's a bit field. And so each bit represents some characteristic or property. So again, trying to parse these just in a raw hex editor is really challenging. Let's see. Debug stripped, yes. 32-bit machine says so. Image file DLL says it's a DLL. That's not a true statement though, because this is an executable. So it's saying that the file is a DLL. This was the spot I was thinking, but I haven't looked at it in a while. And again, it's very easy for me to forget exactly what this is telling me. So in a situation like this, where I would probably just use a tool. Let's see what would be a good one. Go back to the desktop. Let's see, detect it easy. And well, here, let's do this. Okay, so if I'm not entirely sure, like I've kind of forgotten how to tell the difference between the two or how they're being shown, an easy thing might be, this is just kind of off the cuff, I'm thinking is I'm kind of coming here, I'm going to grab a DLL. All right, so here's a utypes.dll. I'm assuming it's a DLL. It should be because it's from the system directory. We can look at that inside of our hex editor. Let's see, we can also take a look at maybe detect it easy. I'll show. Value column. Okay, Roy, let me see if I'm. Oh yeah, you're right. Okay, so that says 0 is the value. Let's see, does that add up? File header characteristics. Oh yeah, okay, thank you. Yep. See, sometimes it's just right in front of me, and I forget. So I don't know. The value column, I just overlooked it. Very easy to do that. So thank you, Roy, for the tip. You can see there it says 0. I guess I'm just confused myself on why that says 1. And the U types, this is an actual DLL file now. You can see there the value is 1. Right. So most of the time, the tools that do the parsing will identify that and tell you, yeah, you're dealing with a DLL file. It's going to be, by and large, the same PE file format. You will generally have more exports than fewer imports. You'll still probably have some imports. The image base and a couple of other nuanced things might be different, but for the most part, they're still just a PE file, and it's very little information here. This 1 bit that's going to indicate or dictate that it's actually a PE file as a DLL. So there you go. Hopefully that answered that, and I didn't confuse anyone. I can be good at confusing myself at times, but that's just the characteristics, and that's what that represents. So if you look at it's this 2-byte member, and if you look at that, it just looks like somewhat random in this sea of bytes, and even if you recognize at that offset is this characteristics field, it can be hard to parse that because it's at the bit level that it's determining what it's representing, right? And so even low level like this, this template can help to parse that. Okay, the optional header, another one, lots of fields here. Usually the ones that I pay attention to the most are going to be things like the address of entry point. Yeah, CFF Explorer is definitely another great option. We won't jump into that one too far, but if you just open up in the Flare VM, open with CFF, the Flare team likes CFF Explorer, so it's kind of the prominent one. It's going to do parsing, and let's see, what did I click on? Let's just do this U types again. Well, anyways, it's a PE parsing utility, so there's a lot of great options. I saw a comment earlier, PE Bear, another great one. Just don't have time to get into all of the tools here, but you'll find this on GitHub. I believe PE Bear's in the Flare VM. Yep, sure is. And then a number of other great projects there as well. Okay, so the optional header. Yeah, right. Yeah, you're probably right. It's probably indicating that it's a 1 bit inside. Yep, I understand. The optional header. So we have, again, a number of fields here. It all depends on what you're looking for, but generally speaking, the address of entry point and the image base are going to be 2 fields that are relevant or helpful. The address of entry is going to be where the once loaded into memory, execution of code will begin. This, I like to point this out because when we get into reversing, let me just close this because, okay, so what I'm going to do, we're going to just take a moment here and detour into Idaville, right click on our executable, open with IDA, and you'll see that I'm just going to kind of skip through all of the normal, let IDA do its work. IDA is going to take us to, give it just a moment here. Turn on line prefixes. Okay, so IDA is going to take us to what it has identified as main. Now, you'll notice that the address for main is the image base plus 1000 hex. So this actually is the beginning of the text section. And you'll see that in just a moment if you're not entirely sure how that can be, because we're going to talk about the sections and that raw alignment is, and then the virtual alignment. We can look at, I've done this in a number of different streams as well, but I think it's always fun to point out, if we turn on opcode bytes, you'll see right here, these are the bytes for the beginning of that section, 4883EC38. And if we go to our hex editor, we scroll down, right, there we go, 4883EC38, blah, 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 right? Those are the bytes. So they line up. But anyways, the point here is like IDA has taken us to main, but it's at an offset of 1,000 hex. And if we look at the image, the address of entry, this is an RVA. It's 12A0. So we add that to the image base, and that would be then the address of entry. Now, IDA does something that's a little different than our hex editor, and that IDA acts like an operating system loader, and it parses this and kind of maps it into what it'll appear like in virtual memory. So this is what it would look like in virtual memory if we were running the program, debugging the program, but that's not the address of entry. And the reason is we can follow the cross references. Cross references just where was main called, where was main utilized. You can hit the X key to do that, and you'll see that it's called here. We just scroll up to the beginning of this function, do the same thing where the cross references to this, and here we have, okay, image base plus the offset 12A0, and IDA calls this start. Right, so right there and right there. Right, so since this was compiled with Visual Studio, there's some compiler-generated code to help with runtime initialization and other things that have to occur before the program is ran. And IDA goes ahead and it tries to identify main being then the point where we have the code that we want to analyze. So that is, in fact, the true entry point. And if you don't recognize that, you'll see that there is some code here that is runtime code. This is really going to initialize the security cookie. This is going to do some other initialization here. It can be really tricky. It can be really tricky here to get to the code that's interesting to you. So if you've not used to working with IDA or just getting started with it, these are some of those important things that you need to identify. Very similar. The comment got brought up about parsing PE files, right? That's kind of a similar thing. If you parse a PE file because let's say you want to do your own disassembly with some other library, well, the address of entry will take you there, and right, and like the parsing is going to happen from there anyway. But that might not be it might not be the main. It might just be the entry point with some runtime code. So it is important to recognize that. That's the whole goal here. Again, I cover that in a lot of videos. So if you're not sure, definitely check out the channel. You'll find some good help there. There's the image base. Image base is just like the preferred where should this get loaded into memory. This can be modified if the operating system is using ASLR, address space layout randomization. It'll change, right? So just something to keep track of. But this is our image base for right now, and you saw in IDA it used that image base. That's where those line, they call them line prefixes in IDA. That's where that came from. We have the section and file alignment. Right? So there's the values there, 4096, so 1000 hex, 200 hex or 512 and base 10. That's just determining now the difference between the alignment in memory and the alignment on disk. That is, create this first section, and then based off of where this section ends, determine the alignment for the next section. And again, in that video that I posted here just recently in the PE file playlist, I go into a bit more detail on how that's actually calculated. Let's see, size of image. You have some more characteristics here in this structure here. I think this is where you're going to have things like your dynamic base. That is, can it use ASLR or not? Is it NX compatible? That is the why am I drawing a blank on that? But like the non-executable stack, other security mechanisms that have been added to help with sort of anti-exploitation of an executable or a DLL. Okay, to the end of this structure then, yeah, Luan, a lot of boilerplate code. If you're not careful, again, the compilers can add quite a bit. So there's a whole art of like determining what you're looking at the code level once you get past this initial sort of triage of the PE file. As we get to the end, right, so I'll just kind of go back up here just to rebase us. We're in the optional header from the NT header. So this is a member, structure member that is part of the image NT headers. And this will end with the data directory. And the data directory is going to be these two member fields. Let me expand one, that are going to contain an RVA, so a relative virtual address and a size. Now, not all of these are RVAs. Some of them are just raw offsets into the file. So depending on what you're looking at, there can be a little bit of discrepancy there. But for the most part, what they're used for, like the most common use case I see when looking at malware is, let's say that the malware needs to resolve its own import table. Well, it will look for then, it'll find a DLL in memory, kernel 32 or NTDLL, and then it'll parse the PE file, much like we're doing, to get the export directory, to then start walking the export directory in order to understand and find function pointers for different library functions that it needs. So that's going to help with that. These are going to be at an offset, a fixed offset from the beginning of the optional header structure, and they're going to be in this fixed order. So you'll see the export directory is, I think, 78 hex from the base of the image optional headers. And then there's other members here, the import table, TLS directory. I don't actually have to deal with that one too often. I don't run across too much malware that's using those, but the most recent video covers that. And so, okay, so that's what those are. Now, if we go back up here, let's close the image NT headers. Let's see, how am I doing on time? Yeah, okay, we're right on time. What follows then are, is an array of image section header structures, and it's just the number of these structures based off of the number of sections. Right? So we saw earlier the number of sections field. We actually counted them based off of the section name, but it's not always easy to do that. But here they actually are, and you'll see off to the side here that 010 is telling us what the name is. If we expand the field, here's the number of members here. But again, there's only usually a handful that I think are, or that I have to really pay any attention to. We've got the name, right? That's just, again, an 8-byte field that's going to be somewhat arbitrary. We have this enum, miscellaneous. Generally speaking, or at least in my experiences, this always represents the virtual size. So we have virtual size and virtual address, right? And these are going to be now values that are used for the section when it's in memory. So as an example, we have the .text section. Its virtual address is 1000 hex. So that means that in memory, from the image base, it'll be at 1000 hex. The virtual size will be 51280. Okay, great. But the pointer to raw and the size of raw, these are the attributes on disk. That means that on disk, I'm going to find this section at an offset of 400 hex. Right, and that's true. Let's close that. Here are all the different sections. So a shortcut to navigate to them is just to select one. Probably was already there. And here we are. We're at an offset of 400 hex. All right. I went ahead and loaded this program because I don't have I don't have any like break or delay in the program. So I just loaded it with the debugger. Debugger doesn't matter as long as it breaks after the image is loaded. And now we can use a tool like System Informer. Here's our process right here. And double click, we got our memory tab. There it is. We just have to find where this is located in memory. Here it is. All right, so here's our image base, and at an offset of 1000 hex, that's where that section is located. So we can double click on that, and you can see, a little hard here with the font, I know, but there's our bytes, 4883EC38. Yeah, okay, Luke, thanks for the comment. This has been years and years of fumbling around with hex editors and other things. So another major motivation for me to do this is there's been so many folks that their content that they made public was so helpful in my learning. I'm trying to pay it forward, I guess, in a way, and help others. So anyways, that's just to see it. We'll spend a lot of time here. I have a video earlier in this series on Process Explorer, and that talks a little bit about that. This is, a great comment here from Lon. When you dump, so again, I don't want to get too far off track here, but this is another reason I bring this up. Even if I wasn't maybe necessarily going to call it out explicitly, I think I was though. Is that when we dump these from memory, this PE file, the minimum, the sections are going to be aligned at those virtual offsets. And so if you dump the file, save it to disk, and now tell something to parse it, like like PEstudio or DI or even IDA Pro, it's going to look at the header information. It's going to parse those sections, and it's going to look for the section at that raw offset. And there may or may not be data there. You might get a bunch of information for IDA, for example, saying, oh, this section appears to be truncated, or you just get gibberish and disassembly. And that's because those sections aren't aligned. Even though IDA takes it and maps it into, and makes it look like it's mapping it into virtual memory, it expects the sections to be aligned at those raw offsets. And so there are a number of tools. For example, PEBear, I think, has a really great capability of redoing those alignments. But all it's really doing under the hood is, like a simple way of doing this would be, okay, we dump a file. We could just make the pointer to raw be the same as the pointer to the virtual address. Right? That is one potential way. I can't say it's going to work 100% of the time, but sometimes if I'm in a hurry, that's all I do. I dump it from memory. If I don't have a tool at hand to help me with the realignment, I just say, okay, the raw offset is also the virtual address. And that oftentimes works. But again, a lot of the tools are going to help you with dumping and recovering PE files from memory. A lot of them are going to do that, or they're going to be able to provide you with opportunity to do that. So definitely keep that in mind. If you take anything away from that last like 30 seconds, is if you're dumping PE files from memory, there's going to be an alignment issue. You need to look into it. So great comment. Okay, so we were talking about the section headers, right? And the difference between the virtual address and the pointer to raw. The sizes, then, that's just going to determine, how much space does that section consume. And that also then helps to determine where the next section is going to be located. So as you navigate through these different section headers, generally speaking, at least in my experience, they're going to be in order, right? The text section will be followed by the R data, which will be followed by the .data, which will be followed by, and so on. I don't know. I did a little bit of looking. I don't know if there's anything that guarantees that. Like in my mind, there's no guarantee that as long as the alignment is done correctly, the text section might actually follow the R data section. They're just laid out in memory. As long as there's no overlap and the data doesn't conflict. I haven't tried it though, so I can't say 100%. But in practice here, I've seen that these generally are in that order. And then again, you just have the different sections here. Tools like O10, right? They might parse things like this debug directory or the import table, and just try to provide you with a slightly more straightforward way of looking at the imports. If you really want a straightforward way, you use tools like PEStudio, Malcat, so forth and so on, because they're going to parse the table for you. But all the information's in here. Again, I've got a video on exports and on imports. And so if you really want to learn exactly how these are being parsed and where all this data resides, even how something like O10 can go from, the import table that simply begins up here in our data directory. Let's scroll down, data directories. There's our import table. Like, how do we go from here to the actual import table? All right, I've got a video that covers that, as well as there's tons of great resources out there. I mean, the PE file's old, so there's lots of great write-ups and different videos and different talks and just stuff that covers it. You'll notice with tools like O10, maybe you notice this off to the side here, there is then, a lot of these values are RVAs, relative virtual addresses. That is, they're expected to be used in the context of this PE file, this image being in memory. And so if we want to parse it on disk, then we have to convert from where it would be in memory to where it would be on disk. And this file, I think this is file offset access or address, but that's just O10 saying, okay, this was actually an RVA and I converted it to find where this thing begins on disk, right? So that can help you with that. And again, many of the videos in the PE file format playlist I have go through that conversion. So yes. Okay. So that's really kind of the gist of the PE file format. Those are some of the, this is the, how you can detect a basic PE file the basic PE file. We have the 2 bytes here to begin, LFA new, then we go to the image NT headers. So some of the more important structures and members inside of the image NT headers. ways that are going to help determine whether it's a DLL or an executable. Where is the image? Where is the address of entry? We had a little bit of the data directory, and then the section headers, and then the sections themselves. And then again, as you can see, our tools are trying to make this more useful, process this information in a way that's a little bit quicker, much quicker to digest and do that sort of triage analysis. Taking that even one step further, if we needed to begin to analyze code, we would need to do what we just did with IDA. Open up the binary, let IDA identify the address of entry point, and start looking at the code, because there's only so much we're going to be able to, to pull or learn at this level. Now, some things to start to, I guess, set the stage for the next, because likely in the next, one of the upcoming Malware Mondays, we'll start talking more about signs, looking for signs of obfuscation. And let's see, I've got detected easy open, right? And so some ways to look at this content and try to identify if there's something abnormal going on to it. Well, something we've been doing throughout, signatures. Signatures are a great way. Yara, maybe the tool has its own built-in signature engine. Entropy is a great one. Let's look at the entropy. Higher entropy would indicate the potential for packed, compressed, encrypted content that then will have to be decrypted in memory as it's being executed. We have things like strings, right? The presence of strings, the absence of strings. Talked about that throughout these different live streams, and we'll continue to build upon that, as well as the imports. Right? Imports are also one where a file that, if it's packed, right, it may have very few imports, because what we're looking at then is an executable that was generated by the packing logic. If it's just trying to be tricky, and a lot of malware, even if it's packed or not, once it's unpacked, it still will dynamically resolve its import table. So you'll see very few or maybe even zero imports, and that can be a sign then that you're still dealing with some layer of obfuscation. So that runtime linking, or that dynamic, I like to call it dynamic API, but runtime linking I think is the more technical term, more accurate term, and that it's going to resolve those at runtime in order just to make our analysis a little bit more challenging. So that's the kind of information that we look for in the PE file, and it's incomplete because we don't know. Like we can make these assessments and judgments based off of what we're looking at, but we won't know 100% until we really start. Like, the answer is in the code, right? You don't always have the time or the skills to get to the code, but the answer is there. And so we're just looking for these signs to help us determine, okay, well, if this thing looks like it's packed, or it's probably doing runtime linking, and it's hiding all of its strings, and I want to know that going into my reversing, because then that'll be one of the first things that I'm looking for is how does it resolve APIs? How does it get its strings? Because those are so important for its functionality, right? Everything it's going to do, by and large, at least things that are usually the most interesting, are going to revolve around, of course, interacting with the operating system through those APIs, and using some level of strings. Yes, you're very welcome. This is probably the end of the stream here, because I feel like I'm entering into ramble mode. So that's usually a good sign to wrap things up. So this was just a crash course in the PE file. Again, lots of great videos on the channel, so check those out. A lot of great resources just across the internet. People that are creating the tools and really understanding the low-level analysis. The videos, if you have questions, comments will be open. Please feel free to leave comments, questions, things you liked or didn't like. I always appreciate constructive feedback, because that helps me to improve, or either improve the content or continue to do things that have been effective. Just keep in mind, we've got a couple of different live streams coming up. Some guests are going to be joining me here in the near future. So do mark those, turn on notifications on the channel so that you get those. Some of these are going to be YouTube only, so do pay attention to that, but I'll make sure to promote them, and looking forward to seeing you all in those live streams. With that, I think I'll wrap everything up. So if there are further questions, thanks, Drew. Thanks for joining. Thanks for everything you do. Drew is one of the community members. It's just been incredible. So not only here in the YouTube world, but also on the Discord server. And if you didn't know, there is a Discord community. You can check it out on my site. I don't think I have a great way to promote that, because let's see, I don't probably have a banner. Well, I'll just make one. There we go. Yeah, so you can go there. You can find a link to the Discord. Come in. It's a place for learning. That's the number one goal. We're not really into sharing threat intelligence. There's plenty of communities that do that. It's a place to come and learn and to share knowledge. I think that's also equally important. If you're looking for a place to, I'm not, here we go again. But I want to mentor, and I love mentoring, but I find that I've tried to do it on an individual basis over the years, and it's always challenging for me because it becomes very, very time consuming. Um, and so, hopefully a part of this community can be a way to come back and share and, to mentor in a way, without feeling the obligation of like committing to someone in a formal program. And we're going to meet once a week for an hour and I'm going to help give you exercises. You can still come in and share knowledge. Drew is one, Karsten is another who is just constantly in there helping answer questions and providing, mentorship in a way that like neither one of them have officially committed to being someone's mentor. So just as important as I think it is for folks to be able to come and ask questions, and no question is dumb. You're not going to get a RTFM from anyone, hopefully, at least certainly not from me. And that's not the kind of environment that we're trying to create here. But it's also a place to share because that's we value everyone's contributions. Okay, well, let's see if I missed any. Okay, one question. Question about decryption. I'm not sure how PEBear does it, and so I'm not entirely sure if there's just certain algorithms that it can detect, maybe compression or something, that it might be able to then get you past a layer. XOR could be one that a tool, if it's a single byte, usually those are fairly easy to recover. Uh, but then anything that's more advanced, RC4 key, anything that's got a key or something, you'd have to be able to recover the key. So I'm not entirely sure how PEBear does that. Maybe I'll take a look at that as a future video content. Usually when I come across encryption, I try to identify it using some sort of a signature, and then I'm dealing with it manually. So I just can't think of any other good scenarios there. So I don't know. I don't know 100% know. But I'll take a look. Worst case, I'll just leave a comment on the video, and hopefully that'll answer your question. Okay, great. Well, thanks everyone. Hope you enjoyed the stream and look forward to seeing you all here in the upcoming streams. So till then, take care.